So we got this question via email about problem set number 4, number 3, and the email was actually about part B, which I'll get to here in just a second. But I figure I'll go ahead and do the whole thing. So we have to find this composite function g of f, right? So keep in mind notationally, this would be the same as g of f of x, right? Where we would substitute f of x into x for g, right? So wherever this x is in g, f of x has to go in its place. So this composite function would look like this. Now, the part of the question was find the domain. Okay? Now, do not just use the function that you came up with in part A. Sometimes it works to find the domain for the composite function. Sometimes you actually might run into some issues, okay? So what you have to consider is that this composite function, I'm going to draw a little picture of what's going on, okay? Now, this circle represents the domain for f of x, okay? Because we take whatever numbers we can use for f of x and we apply that function to it, and then we get some kind of, well, whatever its range is, right? Now, this is also going to represent the domain for g of x. And then we apply g of x, and then we get some kind of range for that over here, right? We get outputs. Here's the tricky part. So I know for g of x, okay, that x cannot, that's supposed to be a little things, x cannot equal 0. Okay. Now, I also know for f of x that since it's a square root, and it was what, square root of 2 minus 6x, that 2 minus 6x has to be greater than or equal to 0, which would mean what we can subtract 2 from both sides. We'll divide by the negative 6. Since we're dividing by a negative number, right? We're dividing by negative 6 here. We have to flip the inequality symbol over. So that means x is going to be less than or equal to 1/3. Okay, you can't just combine these two domains, okay? Because what's happening is in here, this is where you can't have the 0, okay? After you've already done something with it, okay? If you exclude 0 and you did this step by step, then the 0, what happens is if you evaluate f at 0, that's going to be the square root of 2, and then you could evaluate that, and you would come up with negative 5 over square root of 2. That's perfectly fine, right? So it's not 0 that's given the problem. It's what value for x, what x in the original domain gives you an output of 0, because then you would be using that output and trying to apply it to g. Okay? So the question is, when is 2 minus 6x equal to 0? So that turns out to be when x equals 1/3. Okay? So we have to exclude 1/3. If I can get this thing to draw. So we have to exclude 1/3 from the domain, because here's what happens. Again, taking it step by step. If we evaluate our function f at 1/3, the output is that as 0. Then if we try to put 0 in for g, for x, we would wind up with 5 over 0, which is undefined. Okay. So the problems are anywhere where x is greater or less than 1/3, that would be a problem. Okay, I mean, a problem is anywhere greater than or equal to a third, but we also have to throw out the 1/3. Okay. So, yeah, I think I just said that wrong. I had to pause for a second. So, our domain, because of the square root part, we would start with this, but which is negative infinity to 1/3. So you might want to think of it as that. But then, because of this issue, we have to throw out the 1/3. So our domain is actually negative infinity to 1/3 with the parentheses, and that's what we need. Okay, so in all of these cases, you have to go back and look and see which output from the original domain gives you a problem in this domain for the second function, if that makes sense. So I hope this helps.